Having a look at function notation, what I've got written down is just a simple equation, y is equal to 3x take 4. We can write that in another way, like so. Now we call this function notation, and this part here, we just refer to that, or pronounce it as f of x. So we say f of x is equal to 3x take 4. Now when we see this, it really means the same thing as an equation, y is equal to 3x take 4. We're just writing it here in function notation just to help us out with some of the calculations. Okay, let's do a couple of examples. So I've just introduced another function here. So I've got my original function, f of x is equal to 3x take 4. I'm just going to introduce another one using a different pronumeral. G of x is equal to negative 2x plus 8. And again, we could think of this function as y is equal to negative 2x plus 8. But this way, given two functions here, we can differentiate between the functions, one with the f, one with the g. Okay, so let's do a few questions on these. So we've got, first one here, we've got find the function when x is equal to 5. So when we see this sort of notation, what it really means, sort of longhand, I guess you could think of that as the function when x is equal to 5. So really what we're after in this case is we want the value of this function when x is equal to 5. So we simply substitute the x is equal to 5 here. So f at 5 is simply equal to 3 times 5 take 4, which is 15 take 4 is 11. In other words, the value of the function when x is equal to 5 is equal to 11. Second example here, we've got find the value of p for g of p equals negative 14. So in this case here, we're saying that this function, the function g, is equal to negative 14. In other words, this is equal to negative 14 for some p value here that we're trying to find. So in this case here, what we do is we substitute the negative 14 where the g of x is, and we write negative 14 is equal to negative 2. Instead of writing x, I'm just going to write p, just a different pronumeral. We've now got an equation we can easily solve using some balancing. So we just subtract 8 from both sides. We end up with negative 2p equals negative 22. And then dividing both sides by negative 2, we end up with p is equal to positive 11. Negative divided by negative gives a positive. So what that means is that at this p-value of 11, the function of g here will be equal to negative 14. Now the other thing you might be asking yourself is, why are we using this function notation? Why don't we just use the equation notation here instead of the function notation? Now the main reason at this stage is just so we can more easily write things like the value of the function when x is equal to 5. If we were using equation notation here, we would have to say when x equals 5, the value of y is equal to, and then work it out, which is just a bit more difficult to express. Okay, let's do one more example here. Let's try finding... okay, so let's try this one here. Find the value of q for which function at q is equal to g of q. So in this case here, we want to find out where these two functions are equal. I'll just write those functions out again. We had f of x is equal to 3x take 4, and g of x is equal to negative 2x plus 8. So we want to find out where these two functions are equal to each other, at what value of x, or in this case I'm using the pronumeral q. So what we can say is just make this part of f of x equal to this part of g of x, and instead of using x as my pronumeral, I'm going to use q. So we've got 3q take 4 is equal to negative 2q plus 8. So in other words, at this point here, that's when this function will be equal to this function. We can now solve this. So if we add 2q to both sides, we end up with 5q take 4 equals 8. Adding 4 to both sides, we end up with 5q equals 12. And then finally dividing both sides by 5, we get q is equal to 12 over 5. Or if you like, you can think of that as a decimal, 2.4. So what this means is that the two functions, f of x and g of x, will be equal to each other when the x value is equal to 2.4.